LeetCode problem number 994, rotting oranges. So this problem gives us a m times n grid where each cell can have one of three values. So 0 representing an empty cell, 1 representing a fresh orange, 2 representing a rotten orange. Every minute, so any fresh orange that is 4 directionally adjacent to a rotten orange becomes rotten. Here we have to return the minimum number of minutes that must elapse until no cell has a fresh orange. And if this is impossible, then we have to return -1. So impossible would mean if, let's say if this is empty and this is empty, then if this is rotten, so all of these will be rotten except for this, right? So, and no matter how many minutes gone by, there are no adjacent rotten oranges adjacent to this fresh orange, which means that it is impossible, so we have to return -1. So my first approach to this problem is to use a breadth-first search. So we are starting from this orange here, and when the next minute goes by, we will rot these two orange. When the next minute goes by, we rot these two orange. Next minute goes by, we rot this orange, and the last minute we will rot this orange. So in total, it will take us 1 minute, 2 minutes, 3 minutes, and 4 minutes. So to implement my breadth-first search, so here I initialize the m and n values first. So m representing the row size and n representing the column size. Here I keep track of the time needed to rot all the fresh oranges. Here I also have a queue that keeps tracks of all the rotten oranges that we will have to rot the adjacent fresh oranges. So here in my nested for loops, I check if the current cell is a rotten orange. Then I will push the coordinate of that rotten orange cell into the queue. So this vector pair is just a directional vector pair used to go to the up, down, left, and right cells of that rotten orange. Here, while the queue is not empty, which means that we have rotten oranges inside, what I'll do is I will iterate through the rotten oranges, right? So here I save the rotten oranges, the number of rotten oranges in the current minute. I iterate through, and here I have the x and y values of the rotten orange. Remember that we pushed a pair which indicates the x and y values of that orange. Once that is done, I pop it, and then for each direction that I can go up, down, left, and right, I will mark that grid as rotten. So over here, I'll mark the grid as rotten. So I'll mark this and this as rotten. Of course, while marking it, I will push these two new coordinates that I've just marked into my rotten queue. And this will repeat until there's no more rotten size, which in this case there isn't not anymore, because at the first minute there's only 1, and now the second minute there's 2. But let's get back later. So while my rotten queue is not empty, I will increment the time. So right now, my time is 1, and my queue has the following, what is this, 0, 1, and 1, 0. Right, these are the coordinates of the rotten oranges I have now. I repeat the step starting with 0, 1. So I infect these two rotten oranges. I push them back. This is 2, 0, or no, more like 0, 2. And then this is 1, 1. Right, and I pop this. I've done this. And now move on to the next one. And basically this step I'll repeat it. Since I've already infected these oranges, I won't do anything to it. But you can kind of see the breadth-first search taking place. Pop this. And here I'm also pushing a new 1, 1, even though it's already inside. But it shouldn't really matter that much because we are just going to change it to 2 anyways. And when everything is done, I increment the time once again. And basically this will repeat until we have no more oranges, or you repeat until we cannot rot any new oranges, right? Because we are popping as we rot, so these oranges will eventually be empty. And once that is done, to know whether or not we have rot every single orange, we iterate through the cells, each cells of the rotten of the oranges, and check whether or not there are still fresh oranges. If there are, we return -1. If there isn't, we return the time taken to rot every fresh oranges. Okay, so like I mentioned, this is using a breadth-first search method. Breadth-first search meaning we start from the area closest to our original point, and from there we work ourselves to the depths. Okay, hopefully my explanation is pretty straightforward. That's all I have to show. Thanks.